Let's talk about solving for real zeros algebraically, which just means by hand. So recall before we start, right? If I have x squared plus x plus 1 equals 3, we think about this in two pieces, right? Think about what x value, when I plug it into x squared plus x plus 1, will give a y value of 3, right? So that's when we can graph y equals x squared plus x plus 1 and graph y equals 3 and see where they intersect. So this is the same thing as solving just this system, right? We're graphing y equals x squared plus x plus 3 and y equals 3, and we see where they intersect, and these intersect at -2 and +1, okay? All right, let's also recall that the definition of a zero is if we have a function, right, f of x, and the zeros are all the x values for which f of x equals 0, which in layman's terms means y equals 0, right? So if f of x equals 0 and f of x is the same thing as an output, which is y, then this is y equals 0. And when y equals 0, those are all the x-intercepts. So zeros are x-intercepts. Okay, so let's solve this. So we have 3 minus 2x equals -5. And then I want to explain what the solution represents and then graph the solution or graph the equation here to see if my explanation is correct. So algebra so far, not too bad, right? 3 minus 2x equals -5. Let's subtract 3 from both sides. Then let's divide through by -2. And then a negative divided by negative is a positive, and an 8 divided by 2 is 4, so that'll be a positive 4. All right, so when x equals positive 4, then when I plug it into this expression on the left, I should get a y value equals -5. Well, that's my interpretation. That's what this represents, right? The x value. So x equals 4 is the x value of 3x minus 2, good Lord, of 3 minus 2x that produces y equals -5. Well, let's try it. So let's graph it to see if we're right. Well, here is 3x minus 2, right? A nice diagonal line. And then here is y equals -5. And they intersect at x equals 4. So that was true. All right, let's try this. So x squared equals 2x plus 3. Same thing. Solutions, explain them, and then graph them. So here I have x squared minus 2x minus 3. So I moved the 2x and the 3 to the left side. So I subtracted both sides by -2x and subtracted both sides by 3. And that's how I got it equal to 0. And now I'll factor it. So the two factors of -3 that add up to be -2 are -3 and 1. And so now from the zero product property law, I can set x plus 1 equal to 0. So I just need to figure out what makes this 0. And then I can set x minus 3 equal to 0 and figure out what makes this 0. So we can see by looking at it, if I substitute in -1, I'll get a 0 here. So that's a solution. If I substitute in 3, I'll get a 0 here. So that's a solution. So those are my two solutions. All right, and what do my solutions represent? Well, let's start with this equation here. The solutions represent, they're the x values of the left side, x squared, and the right side, 2x plus 3, that produce the same y value. That's what this means in this first equation. That those two x values will produce the same y values if I use the left expression and right expression. Well, let's try it. So I graph y equals x squared. I graph y equals 2x plus 3. And you'll see they intersect at -1, and they intersect right here at 3. So that's true, okay? Well, we can look at it a different way, right? I can look at this equation, right? If I'm solving this equation too, I should get the same solution, which I do, but the interpretation is a little different. So if I solve this equation, it's the x values, the solutions are the x values of this x squared minus 2x minus 3 that produce a y value of 0, right? So depending on where I am in my algebra, my interpretation of the solution is a little different. So now, to see if this is true, let's graph x squared minus 2x minus 3 and see if it intersects at y equals 0. Well, here's x squared minus 2x minus 3. Here's y equals 0. You can see the intersections are -1 and 3. Okay? All right, so stop this, and you want to complete class or problems 1 and 3. Okay, so now let's find the real zeros of 10x squared plus 13x minus 3, and then the same pieces, right? Explain the solutions, what they represent, and then graph them. So now you'll notice I don't have an equation, but it's the term zeros. So when they ask me to find the real zeros, I want to find when the y value is 0. So my first step is to set this equal to 0. Right? And that's why we've been trying to think about this in what the left side, when I plug in x's, when the left side will equal the y side value. And since zeros are when y is 0, that's why I can put a 0 here. Right? Okay, so we can factor. And now it's that weird idea, right, where a combination or factors of 10 that multiply factors of 3 in a special way that add to 13. All right, and if we do that, we'll get 5x minus 1 and 2x minus 3, or plus 3. So first, right, 5x times 2x is 10x squared. There you go. Negative 1 and 3 is negative 3. There you go. And then 5 times 3 is 15. And then negative 1 times 2 is negative 2. So 15 minus 2 is 13. That's how I get the combination. All right. Okay, and now same thing. I need to figure out what I plug into this to make it 0. So I can just do 5x minus 1 equals 0. And I can subtract over or add 1 to both sides, divide by 5, and I'll get a 1/5. And then I can do the same thing here. Set this equal to 0. And then I'll subtract 3, divide by 2, and get a negative 3/2. Right? So that's how I get my pieces. I didn't show it, but you could take this as a separate equation. Take 5x minus 1 off to the side here, set it equal to 0, and solve it. Take 2x plus 3 off to the side here, set it equal to 0, and solve it. You'll get this. Okay? All right, so now what's my explanation? These solutions are the x values of this expression that produce a y value of 0. So to check this, all I need to do is graph this expression here. So make y equals all this and see where it crosses the x-axis. So you can see here's my y equals 10x squared plus 13x minus 2. And it looks like, so on these, right, I'm going by 0.2 or 1/5. So if we look, this is right in the middle, right? So it looks like 1.5 or negative 1.5, which would be negative 3/2. And then this is right at the 5th, the 1/5. So they intersect at the correct places. Okay, so stop this and complete class or problems 8 and 9. All right, so now what I want to do is put this into another kind of application. I want to find the real zeros of the numerator and denominator of this rational function. All right, so I'm not finding the real zeros of the whole thing. I'm just finding it at the top and the bottom. So I'm taking this concept and kind of separating it out. All right, then I want to explain what's going on. Okay, so let's start at the numerator. If I want to find the real zeros of the numerator, I just take the numerator and I set it equal to 0. And then what do? I solve, so I get x equals negative 5. So now what's my interpretation? Well, the solution here is the value of x plus 5 that produces an output of 0. Right? So that's what we're doing. That's all it is. It's what number, if I substitute it into the top, would give me a 0 in the numerator. That's all we're doing. And in fact, that's what we get. So if we plug in negative 5, and I didn't plug it into the denominator, which when I plug in the negative 5 will go everywhere, but I wanted to show you what this looks like. It's really just this we care about, and this divided by 0 divided by anything would be 0, right? So then that means y equals 0. So when I actually substitute in negative 5, when the denominator is 0, the whole thing is 0, which means y is 0. Well, when y is 0, that's the x-axis. So this x equals negative 5 is actually an x-intercept. All right, so what does my solution represent? It represents the value that I substitute into this expression and get an output of 0. And it turns out that in this expression, when that numerator is 0, the whole thing is 0, so it really is an x-intercept. Well, let's see if we're right. So that's all our stuff again. I'll graph this. So if I graph my rational, I'll get this. And you can kind of see right here, it's a little, we need to zoom in a little bit, but you can see it crosses at negative 5. Just like we thought, x equals negative 5 is a x-intercept. All right. Okay. Now let's do the same thing with the denominator. We just take the entire denominator and set it equal to 0. We want to know what makes the denominator 0. So here I have my quadratic. Let's do our factoring. Let's set each piece equal to 0 and solve. So that's how I'll get a negative 2 and a negative 1. And then what's my interpretation? It is simply that these solutions are the x values that make this expression have an output of 0. That's our deal. Okay. Now look, if I plug in 0 here, I'll get a 0 in the denominator. Right? And so now when we can divide by 0, we get an undefined value, right? We can't divide by 0. Because remember, when we divide by 0, it actually it's infinite. Right? So this means that these y values can't exist. So when you divide by 0, this expression is infinite, which means it doesn't exist. All right? So these y values actually also mean, or I'm sorry, these x values mean that they produce or they belong to y values that don't exist. Well, let's check it out. So here's my stuff. Let's graph it. And you can see these dotted lines will go to infinity, and these graphs actually never touch the line. They never touch the dotted lines, which means the x values here and here don't have y values. Okay? All right. Okay, this is actually the end of the video, so stop it and then but complete classwork problem 11.